So with logs, what is a log? Like, how do I... There you go. Logs are exponent finders. They answer the question, when you don't know what power, that's when we use logs. When the power is in question, we use logs. So I teach my math 3 class to use what's called the loop trick. Right? So if you want to solve a log, really what this is saying is 4 to what power equals 1/2. It's just anytime you don't know, you need to solve for an exponent, you use a log. That's why we use logs, right? So in order for it to be 1/2, what power would it need to be? No. What power would it need to be?
Negative.
It would need to be negative. So 4 to the first power is 0, right? Or sorry, not 0, 4. 4 to the 0 power is 1.
So the negative 1/2?
So it's going to have to be a fraction, and it's going to have to be, right? It's going to be a fraction because 4 isn't a fraction. 1/2 is. So it's negative 1/2. So that would be the answer, negative 1/2. Okay, these questions I took from Math 3 book. These are Math 3 questions. They're not calculus questions, but just to remind yourself what a log is. So number 2. X cubed equals 81. What does x equal? How do I solve that? You find the cube root, right?
3.
What times itself 3 times makes 81? I don't think anything, right? Wait. I think this problem's written a lower. I think this number is supposed to be, if I remember right from last year, I think this number is supposed to be 4. Otherwise, it won't make any sense. So the 4th root of 81 is 3. Yeah.
Oh, that's supposed to be 4.
Mm-hmm. So this class, we don't deal with logs too much. That's more of a Math 3 thing. The one we deal with quite exclusively is natural log, ln. So we just did 2 log problems. What's the difference between a log and a natural log?
Natural log e. Base.
So yeah, so log could be base 4, base x. It could be base anything. Logs could be base anything. Natural logs are exclusively when the base is e. E. Right? Euler's number. It's called Euler's number. Euler's number is e. It's kind of like pi in that it's a number, but it's like 2.72 something. Okay? Where does it come from? It comes from this limit question. It comes from this limit. Where does e come from and what is it? Well, if you answer this limit question, you'll get the answer. Okay? You don't need to know what e is in this class. You just need to know what's the difference between a regular log and a natural log, and why is a natural log considered a natural log and not a regular log? Well, because it has a special base. It has a special base of e.
So there will be a special one for like pi as well? Or no?
No, just e. That's the only one. The only special log is natural logs. There's no other logs. Okay? So in this class, we don't really talk about logs. We just find derivatives of them. Okay? We find derivatives of log functions. That's all. Okay? So the 2 functions we're looking at today are exponential and log functions. I highlighted one from each because those are the ones you see quite a bit. I can't think of a problem. There's not many exponentials that don't involve e. And there's not many log questions you'll see in this class that won't have natural log. They like to focus on e and they like to focus on natural log. And there's a reason for that. The reason is These are the easy ones to find. Finding derivatives of these two guys are one of the easiest things to do. Because look, if I'm finding derivative of this guy, what's the first thing that it does? Just repeats itself, right? Whatever it was before repeats itself. And then what does it do? Multiplies by the derivative of what? The power, yeah. That's it. Repeat itself, find the derivative of the power. So, let me give you an example. Let's say, find the derivative of e to the x. How would we find the derivative of e to the x? Rewrite it. And then you multiply times the derivative of the power. What is the derivative of the power? 1. So what is the derivative of e to the x? E to the x. Yeah, e to the x is an easy one because it's the derivative of e to the x is itself. So anytime you see e's, they're not hard.
If it was multiplied by the exponent, aren't you just going to either get 1 or nothing?
Yeah, if it's just a number, if the exponent is just like squared or to the third power, then yeah, you'll get 0. But we're going to deal with other functions up there. Like we'll deal with other things as powers. Okay? If you get a random one like this, if you get like 2 to the x, you're going to use this guy. The natural log of a, so it would be the natural log of 2, times, repeat itself, times the derivative of the power, which is just 1. So it would be 2 to the x times the natural log of 2. But like I said, most of the time they have exponentials. It's going to be e-based. There's going to be e's. Okay? Logs. Same way with logs. I can't remember a problem on a test or a quiz that had a log in it. It was all natural log stuff. It's all natural log. And there's a reason for that. Because look at the derivative of a natural log. How do I find the derivative of a natural log?
You do the derivative of the exponent over the exponent.
Exactly. Just whatever is here, find the derivative up top, repeat itself on the bottom. You're done. So like if I'm finding natural log of x, I'm finding the derivative of a natural log of x,
1 over x.
it would be on top would be the derivative of the log, right? This part here, which is 1. Bottom, it repeats. Done. Okay? So they're not hard. They're not hard at all. But, you know, when you see them, you kind of have a pause because you're like, uh-oh, log, or uh-oh, exponential. But it's really not bad.
So what we did is basically the next 2 problems.
Pretty much, yeah. Pretty much what we did was the first 2 problems. So let's take a look at example number 1. It's a log. How do I know? It's got the word log, ln, natural log. So here's the inside stuff. Oops. So let's go to the derivative. Yep. So the derivative of the log part goes on top. The bottom just repeats.
Then would the 4s cancel?
And then you would cancel out the 4s, reduce the fraction, divide them both by 1 or 4, and you get 1 over x. Done. Okay. Next guy, it's another log. So the derivative of the inside is 2x. The bottom just repeats itself. Done.
And then if we're asked for like, I forgot what they're called, but like when we do the derivative again, again, like if we're asked for that, will we just do the same way? Or
Yeah, we're going to see problems like that. Yeah, good question. We're going to see problems like that as we get going. So I just put a bunch of different logs on here. Threw in some power or roots, threw in some fractions, just a bunch of different stuff in here just to kind of give you an idea of what we do. Okay? So you're finding the natural log of this stuff here. Okay? So the derivative of the stuff goes on top. Okay? The derivative of the stuff goes on top. So what would be the derivative? Hey,
6x minus
thanks.
5?
6x minus 5, good. Bottom repeats. Done. Okay. Letter D. What's the first thing we always do?
Get rid of the root.
Get rid of the root, right? So let's rewrite this. So this should be written as natural log x to the 1/2. Sometimes I put parentheses around the log part like they did in C. Sometimes I don't. I always try to put parentheses around, right? Because the 1/2 goes with just x. It doesn't go with the natural log part. Okay? The top is the derivative. The bottom repeats. So the bottom is always, I always start with the bottom because the bottom just repeats. So the bottom is just going to be x to the 1/2. The top is going to be the derivative of the green. I'm just going to use the power rule. 1/2 times x to the negative 1/2.
Which is 1 over x. 2x.
There you go, right? So this guy is going to move down because it's got a negative power. The 2 is going to move down since it's in the denominator. So the only thing that's going to stay on top is 1. And then you get 2. And then I have square root of x times the square root of x. Well, the square root of x times the square root of x is just x. Done. Okay. So now what they're going to do is they're going to mix in, we've only used really the log rule. We've used the power rule. So now they're going to mix in things like the product rule, the quotient rule, the chain rule, things like that. It's the same thing though. You're not doing anything different. The first guy, I'm going to have to use the product rule because it's multiplication. Right? And then this is what I'm talking about. They don't have the parentheses around the x. I always do. Is it necessary? Is it needed? No. But I always do, just force a habit. So we're going to use the product rule. The product says the first times the derivative of the second. X squared times, what's the derivative of natural log?
1 over x.
1 over x. We did that on the first page, right? 1 over x. Plus the natural log of x repeated, the second, times the derivative of the first, which is 2x. So I have x squared over x plus 2x times the natural log of x. Well, I can cancel out this with 1 power. So I get x plus 2x times the natural log of x.
So is that just 3x then?
No, because they're not like terms. Okay. Next one, quotient rule. Or you can change it to, you can leave it like that and do the quotient rule.
Change it to -1.
Or, yeah, you can move the bottom guy up and say natural log of x times x to the -1 and do the product rule. Doesn't matter which one you use. Doesn't matter which one. Like I said, whichever one you want. I'm going to use the quotient rule since we haven't used the quotient rule yet. So the bottom is the bottom squared, x squared, low times, and now we're going to do the top. Low times the derivative of the high. The derivative of natural log of x is 1 over x. We just talked about that. Minus the high times the derivative of the low. Okay, these guys are going to cancel out to make 1. So you're going to get 1 minus the natural log of x. That's it. Okay. Let's try, oh, that's it for logs. We'll come back to logs, but let's go to exponentials now. Exponentials now. So exponentials are even easier because if it's got an e and you're taking derivative, it repeats itself times the derivative of whatever the power is. So instead of focusing in on what's in the parentheses, you're going to focus in on what the power is. Okay? So I'm focusing in on what the power is. So if I'm finding derivative, dy over dx equals, it's got an e. First thing it's going to do is repeat itself. Times the derivative of the power, 2. So it would be 2 times e to the 2x minus 1. Okay. Next one. Same thing. If you're taking derivative, first thing it's going to do is repeat itself. Now, that guy, the green part, you can use the quotient rule, but I'd probably rather use the power rule and just move it up like that, 3x to the -1. If I do that, then I can just use the power rule. So I'm going to get -3e to the 3 over x over x squared, because this part's got to move to the bottom. Done. The hardest part about these guys isn't the log or the exponential part. It's just, it's the other parts of it. Okay? All right. Okay, that's it. That's pretty much, that's the notes. I want to give you some extra practice. So I'm going to give you different types of problems. So the next page is just different types of problems with e's, with logs, all that types of stuff. Okay? So let's look at C. Yeah, we're going to have to use the chain rule for this. 2C. I have something to a power. Something to the third power. That's the outer shell. The inner shell is x plus, or sorry, e to the x plus 3. So move the 3 to the front. Inside repeats, subtract a power, chain. Now find the derivative of the yellow. E to the x, the derivative of e to the x is just e to the x. We talked about that. Plus the derivative of 3 is just 0. So really it's just plus 0. E to the x plus 3 squared. The hardest part about these is not doing the actual stuff. It's recognizing what I need to do. It's looking at this. It's looking at this guy right here and saying, what do I need to do? Okay? Are you following along with this? Okay. Next one, letter D. Which one, what are we gonna do?
I mean, the
Product rule, yep, product rule. Because it's x times e to the x. So the product rule we've used many times before. We're gonna use it just like we've done many times. Product rule says the first times the derivative of the second. What's the derivative of the second? Itself, right? E to the x. Plus the derivative of the first times the second. So you get x e to the x plus e to the x. Sometimes you can factor that because they both have an e to the x. So you might see it like this if it's a multiple choice question. Both of those are the same. If it's free response, either one. But most of these questions you're going to see are going to be multiple choice questions. The free response ones I'll show you later. But for right now, these are kind of the more basic stuff. Okay, so let's go down to this guy.
Can you go back up?
Oops, did I skip some letters? There you go. E.
Thank you.
No problem. Okay, so the next one, E. Now we have an E, we do have an E. And the power is trig. Well, it's not going to change anything, right? It's not going to change anything. So if we need to find derivative of this guy, how do we find a derivative of anything with an E?
you get the first one and multiply it by the second.
Rewrite the whole thing. It always starts with a rewrite. Rewrite the whole thing. Times the derivative of the power, yeah. The derivative of the power. The derivative of the power is just cosine of x. You can move the cosine to the front or you can leave it there. No, it's not a requirement either way. Okay. Let's look at the next one. So this one's got a mixture of both. It has natural logs and it has e in it. So is this one more of a natural log or more of an exponential?
Natural log?
It's more of an, natural log. Oh, okay. There you go.
Thank you.
It's more of a natural log. This one's more of a natural log. I know it's got an e in it, but this one's a natural log problem with an e inside of it. Okay? So this is the inside part, right? So let's go. So if we're finding derivatives of a natural log, always going to be a fraction. Rewrite the whole thing on the bottom. So when I say rewrite the whole thing, I don't mean the natural log part too, because we're finding derivative. Just the green part. Just the green part. So the green part's going to go on the bottom. And then the derivative of the green part goes on top. The derivative of x is 1. This guy just repeats itself. So it's 1 plus e to the x. Okay. They like doing that. They like mixing up these things to see, do you know, is it an exponential problem or is this a log problem? They like to do that. Sometimes what they'll do is they'll reverse it. They'll do this. They'll do e to the natural log of x plus 2. You don't have to write this down, but they'll do that. Is this one more of an e or more of an exponential, or is it more of a log? It's more of an exponential. It has a log in it, but it's more of an exponential. So that's how you know where you start. Which rule do I use? Whichever one is the...
Mr. Flores, can you also cancel out the e to the x's?
I can't because they're binomials. 1 plus x plus, so they're not the same binomial. Okay. All right, so now let's go back to some log stuff. So this one is similar to one we did a few pages ago. Well, this time it's derivative of the whole thing. Or sorry, root of the whole thing, right? So I'm gonna use the chain rule, yeah. So I'm gonna need to rewrite this. Y equals natural log of x to the 1/2 power. Now it's a chain rule problem. It's a chain rule problem. I have an outside and I have an inside. Move the 1/2 to the front, rewrite the inside, subtract a power, chain. What's the derivative of the yellow? 1 over x, right? The derivative of natural log is just 1 over x. Okay, calculus is done. Let me clean it up a little bit. Okay, there's going to be some things that move to the denominator. The 2, the x, and this guy are going to need to move down because 2 and x is already there. 2x. And then the natural log. And then the only thing on top is 1. Okay. Okay, so let's look at B. This one has a natural log in it, but it's more of a trig. It's more of a cosine problem. It's more of a cosine problem, right? It's cosine of this stuff here. That's the angle part. The yellow is the angle part. So we're going to use the chain rule. The outside it's more of a cosine problem. We just said it's more of a cosine problem. So I got to do derivative of cosine. What's the derivative of cosine? Negative sine, repeat. Like I said, most of the time I put parentheses around this guy. It's not needed if it's just x, but. Okay. Now what's the derivative of the yellow? 1 over x. X has got to move down. Everything else can stay. All right. So natural log and they tend to go faster because their derivatives aren't hard, right? But you got to have a plan. Before you do any of these problems, you got to have a plan on what you're going to do. If you can have a plan, it's easy. The problems aren't hard. But if you don't have a plan and you just kind of looking at this and you don't know what to do, that's the hard part. Okay? So what's the first thing I got to do before I do anything? Change it so that it is no root and has a power. So natural log to the 1/2 x squared minus 1, x squared plus 1. It's natural log of the whole thing. So it's a natural log problem. So the natural log, so we got to use the natural log rule, right? The natural log says, what does the natural log say? What goes on top, what goes on bottom? Derivative on top, repeated on the bottom, right? So it's going to repeat on the bottom. We don't write the natural log part, just the other part. So that part repeats. And then we have to find the derivative of that on top. That's where we're going to use the chain rule. Because to find the derivative, I'm going to give myself some more room here. To find the derivative, I got to use the chain rule for this guy. 1/2 to the front. Subtract a power times. Derivative of the inside. Derivative of the inside, I'm going to have to use the quotient rule. The quotient rule says the bottom squared okay, low times the derivative of the high minus the high times the derivative of the low. Okay, so a lot of things I got to do. Let's see. So let me do this. Let me distribute first. Distribute first. Okay, so I get 1/2. Then this guy gets a power. This guy gets a power. Times. Okay. So x squared plus 1 squared. So then it's going to be 2x squared plus 2x minus 2x squared minus 2x. And then the bottom stays the same. Okay, so now I got to distribute the negative. When I distribute the negative, yeah. Cube. Yes, yep, they both should be cubed. Yep, you're absolutely right. because they were squared before, so they should be cubed. Yep. Okay, let's see. Got a 1/2 times. So I have 2x cubed plus 2x. Then I have minus 2x cubed plus 2x over x squared plus 1. And then the bottom is x squared minus 1 over x squared plus 1. Okay. And then the 2x cubes go away, and it makes a 4x. Okay. Okay. So we got 1/2 times x squared minus 1, negative 1/2. Over x squared plus 1, negative 1/2 times 4x, x squared plus 1 squared. And the bottom remains the same. Shane, you writing all this down?
Yes.
Okay, put the phone away. Okay. So now we got 1/2. Okay, so we got 4x. Wait. So I'm going to skip some steps here because it's a lot easier to skip some steps. So on top, I get 1, this guy, this guy. X squared minus 1, 4x. On bottom, I could combine these two guys because they have the same base, add their exponents, you're going to get 3 over 2. X squared plus 1, 3 over 2. And then this guy's got a negative exponent, so you're going to move it down. And then the 2 and the 4 are going to simplify. That's going to be a 2. That's going to be a 1. Let's see. So you get 2x over x squared minus 1 to the positive 1/2 times x squared plus 1 to the 3 over 2 over this guy. You can keep going from there, but I'm just going to stop there because we have a couple more problems to do. But that's, again, the long part of this wasn't calculus. The long part of it was canceling things out and everything.
So would this be a free response or a multiple choice?
Free response, yeah, free response. Yeah, this wouldn't, yeah, this problem here, the ones that usually take you a little longer, they wouldn't put on multiple choice tests just because they know it takes you some time to do this. This question isn't hard, it's just, it's tedious. There's a lot of little things to it, okay? Yeah, so if you were to see the one like this, it would be a free response type, okay? Okay. So let's focus on the last two. The last two, 4 and supposed to be 4 and 5. I don't know what 6, supposed to be 4 and 5. Okay, because these are the types of problems that you will see on both. I've seen these types of problems on multiple choice and free response, 4 and 5. Okay, so I definitely, that's why I included them in there. Because it's a mixture. I see some LNs, I see some E's, right? Okay. Well, you got some pluses in the middle. So that means we just find the derivative of each. So let's do the derivative of this guy, the green guy, first. What's the derivative of the, what's the process for finding derivative of the green guy?
Rewrite it and then you put the power.
Start with a rewriting, yep. Start with a rewrite. And then we find the derivative of the power. Well, here's the thing. It's not tangent of x, it's tangent of 3x. So for tangent of 3x,
You have to use the chain rule.
I have to use the chain rule, yeah. For tangent of 3x, I have to say, okay, well, that guy's the outside, that guy's the inside. So the derivative of tangent is secant squared. Secant squared 3x times the derivative of the inside, which is 3, plus. That's the derivative of the green. The middle is the first time we're seeing an actual exponential without an e. This is an exponential without an e. How do I know? It's got a power. The power is x. So this one we're going to need to go back to our first page to see what how to proceed with this guy. Okay, so let's go. It's a regular exponential. So here we go.
You have to do natural log of the base number times.
So so 6 is the base, x squared is the power, right? So we say natural log of the base times rewritten, everything rewritten, times the derivative of the power. Those are the three things we need to do. Natural log of the base, so natural log of 6, times, rewrite it. Rewrite the whole thing. Whatever you had before, you rewrite it. Times the derivative of the power. Okay. So natural log of the base, natural log of 6, times. Rewrite it, times the derivative of the power, which is 2x, plus natural log of secant of x. That's a natural log problem. So natural log says rewrite whatever you're finding the natural log of. So secant of x goes on bottom. On top is the derivative. The derivative of secant x is secant x times tangent x. Since it's multiplication on top, the secants will go away. It's not secant x plus tangent of x, it's secant of x times tangent of x. All right, so the first term, let's see, the first term is 3 times tangent of 3x times secant squared of 3x. That's the first term. The second term is 2x times 6 to the x squared times natural log of 6. And then the last term is just tangent of x. So it's just 3 individual problems combined into one. That's the only difference between that one and the ones we've done before. Okay. All right, one more. One more and we're done. So number 5, first thing we're gonna do is find the derivative. So find the derivative of that guy. Find the derivative of, I know some of you guys are still writing this down, so find the derivative of y, find y prime. That's the first thing we gotta do. Equation of the tangent line, find y prime. So the derivative is 8x minus, and then I got to use my natural log. Minus, the bottom repeats itself. The top is the derivative. Done. That's the derivative. So now I got to figure out what the slope is, because I know my point. My point's at 1, 4. I know my point's at 1, 4. I just got to find the slope. So how do I find the slope? Plug in 1 to the derivative, yeah. Slope your... So plug in 1, plug in 1, plug in 1. Let's see, you get 8 minus 4 over 1.
2.
You get 2 minus 1, right? So 2. So yeah, the whole answer would be 2, yeah. Because 8 over 1 would be 2. Done. Okay.
8 minus 4 is 4.
Did I get 8 minus 4? Oh, it's 4, sorry. Yep. I did division in my head for some reason. Sorry, yep. That's 4. Okay. So tomorrow I'm not going to be on campus tomorrow because I have a meeting off campus. So all I'm going to leave is the second page you guys have, practice 11. Okay. I'll be back on Wednesday. Wednesday and Thursday we're going to review for the quiz. So I'll be back on Wednesday. So I'm going to post the answer key to practice 11. That's what I'm going to have you guys work on tomorrow.